Okay, chain rule of derivatives. So if you're a function, so if y is equal to a function to a power, the derivative, or y prime of that, would be taking the power, turning it into a coefficient. So very similar like the derivative of any of them, and then deriving the inside, so the original function within. So how does that help us here? We have roots. We're not really dealing with exponents. That's fine. We can actually turn everything into an exponent. So if we decide to turn this into a set of brackets to the power of a half, we then have 2x. And I'm going to do the same with the inside here. This is a set of brackets squared to a half again. So we're actually going to go through this chain rule, it looks like twice here. So it's going to be a pretty long one, so I'm going to actually move a little over to the left. So when I go to find f prime, or y prime, whatever you want to call it, first we're going to have the original. So we bring down this coefficient of a half, and everything within stays the same. So 2x minus, I'm going to leave this in brackets because we'll do all of our converting back to a root function at the end, to the power of negative a half. And then we have to derive what's within the function. So the derivative of 2x is just 2, okay? Minus, well, the derivative of this, that's another chain rule. So just be aware what we're going to do here for this one is I'm going to do the same thing. Bring down the half, keep the middle the same, and then multiply it by that. So the derivative of this becomes 1/2 times the original inside to the power of negative a half. And then that, here's the bigger set of brackets. Actually, I don't want the bigger set of brackets yet. I want another set of brackets times that. So derivative of the inside would be 5 plus 2x, and then the bigger set of brackets is around that. So I kind of did a lot in one step. Are you okay with how I did that? So the next step is just a lot of simplification to everything. So how do we simplify this function? I'm going to leave this as a half. This here I can make a positive root if I just put it all below 1. So essentially think of it, I'm going to turn this exponent to be positive. So it would be 1 over all of that. So I'll do it one step at a time instead of speeding through it. So what do I do now? Well, I just write all of this. So 2x minus 5x to the half. And then all of this is to the positive a half, okay? And then this part here, is there, oh, there is a plus there, thank you. I left that out. And then this is time. So think of this as a function within itself. So we'll kind of put a red set of brackets around it. That was that part here. And then we have another function. Well, this function actually is going to stay on top. So it becomes 2 minus a half. And then this part here is similar to that. I can put this 5x plus x squared to the power of positive a half. And then this is also times 5 plus 2x. I really wish I wrote smaller. So really the hardest part about this question, granted the chain rule was a little tough, is the simplification of this is pretty complex. So we'll try to get it as simple as we think we can. These are just going to be roots on the bottom of the function. And then this 2, I can kind of just write as a coefficient in front. So think of it like we're multiplying fractions now. So this is one term. I've kind of done it in red here. So think of the half as a term, this set of brackets as a term, and this set of brackets as a term. So when we multiply fractions, we do the top by the top. So 1 times 1 is 1. So really it's 1 times this. So all of this is now the numerator of this fraction. We're just going to pull that all in. The bottom, well, this part here, times 2, well, I'm just going to put the 2 in front of it, and then times 1, that won't change anything. So it's just going to be 2 in front of all of this as the denominator. So the top of our fraction, again, is going to read, and I'll keep it in brackets, just the original of this part here. So 2 minus, and this is 1/2 times, and I'm going to start turning things into roots, okay? So 1 over, I'm going to put that back into a root, so the root of 5x plus x squared. Technically, I didn't even do this part yet. This is still the same idea. This is a fraction of a kind of like fractions times each other, so I'm going to multiply that after. But this is still just the numerator, the top of the original. And now let's do the denominator on the bottom here. We have 2 times, and again, I'm going to start putting our roots in. This is a root of 2x minus, this is also a root, square root of 5x plus x squared. Okay, so the bottom is about simplified as far as we're going to really work with it. The top I can kind of simplify this part here just a little bit more, and it's essentially doing what we did to the bigger part of this, now just to the smaller part. Same idea, 1 times 1 is 1, so this is going to be our new numerator, and here 1 times all of this doesn't matter, so I'm going to bring this 2, and the 2 is just going to sit in front of the root, just the same way we did this one here. So let's bring this down. So we're left with bracket. And I actually don't need the brackets anymore. I'm going to keep it 2, subtract, and this bracket will read 5 plus 2x. So we brought that numerator in. It took over everything. And the bottom of this, and I already turned that into root, becomes 2, the root of 5x plus x squared. It's hard to see, I know. All divided by thing on the bottom. 2. Oh, can I just copy and paste it? Yes. Lazy me. Clone. It's okay. Put it over top, and now I just have to draw a line. I don't know if that was actually faster, but that root kind of goes there. So here's our function. I'm going to give it another quick look to see if there's any other simplification I can do here. I mean, I could create common denominators between the value of 2. I'm not going to say that's actually going to simplify the function. It actually might make it a little more difficult to look at, because we're going to be looking at something like 4 root 5x plus x squared over 2 root 5x plus x squared, or that's all under that. Whether that's more simplified or less simplified, it's kind of dependent on your idea of a simplification. I mean, the value of 2 is kind of helpful. And then this here, same idea. We have our exponents. There's not much we can do to the inside. So this is about as simplified as this question is going to be. Pretty complex answer in the very, very end here.